an Earth Cube project, building block, of which Praveen is the PI. Mustafa is doing a lot of semantic work on it, and that's using IML CZO data. And there's also, well, the Critical Zone Observatory, which you know, and a few other kind of sub-infrastructure grants at the top, such as, or at the bottom, such as the DIPS Award, Brown Dog Award. We also use it on some supercomputing resources, but that's not as interesting to you. I don't know why I just froze up. Okay, oh, it was just slow. Okay. All right, so now we look at, here's a page for a specific file. There's a simple preview that shows you the rows inside the file, but basically when we get, and I'll say more about it in a second, when we get the raw files from the sensor, depending on how we get them, we put them in the system and you have the raw files. Then the content of the raw files ends up in the GEO dashboard in a variety of ways, and I will describe that in a second. You have basic information such as license, social tagging, you know, who uploaded it, when they uploaded it, basic metadata information available, all that kind of basic stuff inside the system. But like I said, files here, there's no requirement on what file you upload. So here's just an image from a telephone that was taken in one of the first meeting, the IML CZO meeting in Iowa. I don't have a slide in here, but we have, for example, support for previewers for shapefiles. So when you upload a shapefile, this is not deployed to the live site right now, but when you upload a shapefile, it will show you a map and it will allow you to zoom in and out using the GEO server to actually provide the layer. This is one of the big ideas here, which is very simple, but we want the researchers to upload data themselves and not go through the data managers necessarily, and then have that curation happen inside the system organically. So this is just the page for how you create a data set. You provide a name, a description, some other metadata. You can provide a bunch of files, and then you say create data set, and it becomes a data set inside the system, and it's available for everyone to see. This is something that we've been doing recently, is that as you can tell, there's kind of a divide between the GEO dashboard and, you know, and Clouder, but they really are driven by the same software under the hood, and we're making it easier for the users to actually relate the data sets to the sensors. This is, again, one of the things that we could do before, but we had to do it manually inside the system, right, inside the database or through the API. We're adding a GUI to do this so that, again, the research can say, well, I've just created a data set, and now this data set is related to Big Ditch, right, where Big Ditch is one of the locations on the GEO dashboard. So they click assign, now there is that relationship, and then, you know, the system can use the relationship for further activities. We're also adding simple GUI to manage these sites. When we showed the GEO dashboard, I think 2 years ago, we didn't have this. This is just basically kind of a way for the researcher to come in here and add, edit, and delete locations on the GEO dashboard. So this is just a listing page. This is a screenshot of the form that a user can use to add one of these sites on the GEO dashboard. A lot of the stuff, you know, I mean, it's available on the site, but we're tweaking right now as we get more data in, as we get more feedback from the users. This is kind of something that we showed in the past that I think is very relevant to our conversation today, which I will say a little bit more about it. But everything that you saw both in Clouder and the GeoStreaming API is available through a RESTful API. We prefer JSON. Most of our services pick JSON by default. What we're currently doing is we're starting to annotate the JSON with some semantic information using JSON LD linked data. So we have the ability of providing a context on the JSON document that gives you some of the vocabulary used, some of basically it defines what's in the JSON document. Now, we're doing that right now at the level of Clouder and the metadata in Clouder. We have just started discussing how we can put that in the GeoStreaming API, of which this is an example of. So this is a specific data point. So you can see that the properties element says river stage, ISCO sample, discharge, CMS, blah, blah, blah. So this is a particular sample. It would be, from a logger, kind of file from a sensor 1 row, right? This is compatible with GeoJSON, so that people can just call the API and show it on a map if they really want to. So what do we have in here? We have some extra stuff on top of GeoJSON. We have a start time and an end time. We have when it was added to the system. We have a local internal ID at the top. We have the properties, which is a generic document that we can put different things in. Some of the things are shown in the dashboard, some are not. Type features, that's a GeoJSON definition. Geometry, again, GeoJSON. In this case, it's point. JSON also allows you to have polygons in here. We don't really use them very much at this point for this project. And then there is this kind of stream ID, sensor ID, and sensor name, which I'll describe in a second. So this is the raw data point. Oops, okay. I should have clicked on that first. Okay, so we have data points, which I just showed, which is the kind of the lowest common denominator for the geo-dashboard. Then they're aggregated as streams, and we put some metadata on the stream. For example, in this case, there is a source there. I don't know how easy you can read it, but in the properties subdocument, you can see source, and there is data, IML CZO, Clouder, data set, and the specific data set. So it basically says this streams maps to this data set in Clouder, and at the bottom we say, here are some parameters that we know are available in the data points, and start time and end time for the entire stream. And then streams are inside sensors, and so here is the sensor SWS 105, which you can see on the GeoDashboard with some basic information about it, such as the one that we kind of visualize on, for example, the region, Illinois, some stuff for the GeoDashboard for pretty printing showing the title of the site, like ISWS Stream and Nutrient Station. Again, a list of parameters available there. So the reason why, well, maybe I'm jumping the gun. I'll get to it. But, the idea here is that, we really want the clients to be able to take out, take the data out as easy as possible, both, the machines as well as the humans using the GUI. This is a simple example of a query to get data points by geocoding. This is a polygon between a certain start time, end time, specifying what the source is, the attributes. All of these are things that show up in the GUI. You can do it through the API, and we support two formats for this particular endpoint. One is JSON, and the other one is CSV, because are easier, have an easier time with CSV, obviously. Okay, so real quick, here's an example for one particular location, SWS. What we have is, we have the researcher at the Illinois State Water Survey. They have a Windows Share folder that they put their files in after they've gone through a very simple QA/QC. In fact, I don't even think there is very much QA/QC at this point for this particular location. This is 105. They just put the output of the logger file inside the directory. We have this simple process here at NCSA that monitors that directory. And then in this particular case, we put the raw files inside Clouder, and we put the data points. So we extract each row as one of these data points that I've just shown, and we put it in a special index that under the hood it's running Postgres and PostGIS that drives the GeoStreaming API, the GeoDashboard. And then we have a link between the two inside the GUI that we can establish either at the, the harvester can do that or a user can do that. But so again, to emphasize that, our data goes in two different places most of the time, and then the question is, how does it end up in this data points kind of API? So in terms of moving forward, there's a lot that we're doing. One is, so we have some of the basic technology in place. We're tweaking it, but we need to do more user training because we really want the researchers to be doing this and not have to go through a data manager that does all the manual uploading and so on. So we're putting a lot of the stuff in place while we need to train the users. We're obviously putting more data sources in. This is taking longer than we expected, but it's teaching us a lot about the data and what our services can do. So the LiDAR is one example. We're trying to simplify and enhance the user interfaces based on, and we will, based on this feedback. One of the things that we really want to do that I put in the document is we're very excited about your Yoda Display Files 2.0 approach. And what we really hope is, we've neglected CZOZone.org in the sense that we haven't manually uploaded data sets, partially because we're trying to figure out that internally. Now that we actually have data, we can do that. We could go inside CZOZone.org and add data sets manually, but maybe we can also just simply give you a YODA version of some of this metadata we already have in the system. And what this means is that we would be adding to our software basically a YODA serialization of the metadata. Obviously, we have to work closely with you to make sure that we're giving you the right information, but we would like to develop that ability and then, basically say, well, the moment somebody adds something inside Clowder, then, the YODA file gets updated, right? I mean, it's created on the fly. So that's one idea. You probably have other ideas, but, we hope that this is, moving forward, something that we can potentially do in the short term, depending on what you require in the YODA file. On SEED, we've been working really, really hard, and this hasn't been released yet, but it will be in the next couple of months. We've been working really, really hard as part of one instance of Clowder to have this idea of project spaces. And this is very important for IML CZO because right now there's one space. So all the data goes there, and it's just shared with everyone. Well, we want to start allowing users to have their own private space. So we have, the different teams, for example, could have their own private space so that they have a choice in when they make the metadata about the data sets available to the world versus when it's only available to the members of the different teams. So that's what we're going to use this for. But it's basically what it is like here's a listing for SEED of the different project spaces that we have. In each one of them has a bunch of data sets, files, and users associated with it. Unless you have access to one of these spaces, you can't see the data sets and collections like you can right now. And there's ways to share these data sets and collections among different spaces. So again, this is work in progress. Last thing, and I'm done, is this idea that we have most of the pieces to get this flow working, but this is kind of our ideal flow. And that is, with the one that I showed you, the harvester, requires us to write an harvester for each example, each instance of the data, so that, for example, if some researcher wants to put their data in one place, we create this harvester, and then it has to be specific to that data. But we want to create a system that is much more easier to maintain, so that when the user gets the logger file and uploads it to Clowder using the GUI that I showed, then because we have a link between the data set in Clowder and the sensor location in the geodashboard, the specific extractor for the data type gets executed. So the final, basically our dream is to make it so that all the user needs to do is go in there and say this data set is related to this sensor, and then every time somebody uploads a file, then not only you have the raw files with the raw data points, but you also get the data points to end up in the GeoStreaming API and the GeoDashboard representation. So I don't know how long that was. I wasn't keeping track of time, at least not on the screen. I think that was 22. That's pretty good. I'll shut up and I'll take questions.
Thank you, Luigi.
You're welcome.
Does anybody have any clarifying questions for Luigi about what they've developed and how they manage data?
We could easily get sucked into this is Emilia, by the way, into really fun discussions about what you're doing and how that could match what we're doing. I suspect that would be better for further follow-up discussions.
Okay. Yeah, there are a number of ways in which we might collaborate. We've touched on this over the last couple of years, but it seems like moving forward, we really could find a lot of exciting ways to collaborate with your team.
My basic one question just right now is Clowder, and then there was seed and meta-seed before. How are these things related?
Yeah, apologies. Yes. We basically, for version for version 2 of Medici, we decided to rebrand it to Clowder for many reasons. There were other projects that were named Medici that did similar things with data at other institutions, and we thought that it was different enough that we could basically rebrand it. And so the thing is, when you see Clowder, so if you're familiar, for example, with Seed was using Medici version 1. We will be releasing a version 2 of Seed, which will be using Clowder. In terms of the code base, they share 0. In terms of the conceptual ideas, they share a lot. So,
all right.
yeah, the code base, though, is very, very different between Medici and Clowder. And one of the reasons is because we really wanted this to scale to very large data sets. The infrastructure we had in place before wouldn't do that. Now, one last thing, Clowder has been in development for many years now. We started this about 2 years ago, probably. It's just that we have yet to release an official 1.0. We use it on several projects. That will come soon. We're in the process of hardening and making sure that we have all the features we want for 1.0. But I can definitely say more about it if there is interest afterwards. Does that answer your question? That was David?
I think that answers it. Yes.
That was actually my question. So that's really useful to know. So CED, got it. I think I just encapsulated that. That's really interesting. If you all remember, when we talked to you 2 years ago, we were talking about wondering if we could use Medici because we were really grappling with how to create the CZO central catalog and what software to use. And Medici version 1 was one of the ones we were thinking about.
Yeah, and we did show you Medici version 1, and because at that point we really couldn't show much of Clowder. But Clowder, I believe it's much more mature. Obviously it's much more mature now, but it might give you more of what you need, even if you're not interested at this point. All I'm saying is there's a lot more there in terms of functionality than there was ever in Medici. All
right. Well, I think that some of this topic about how we might collaborate in the future, we should put to the very end of the agenda when we talk about future needs, basically trying to get some ideas for our renewal proposal, which we hopefully will be submitting this winter or sooner. So there really could be some possibilities here to leverage Clowder. Any other clarifying questions about their system, or should we move on to kind of the next part of the agenda, which is really about how the IML team might interface with the guidelines and products that we've developed and we've presented. They can ask us questions about what we have, and we could talk about that next. We ready for that next one? All right, Luigi, on the questionnaire file, which we've been using as a notes file, a lot of people have been typing in it. Near the top, right underneath Overview of CZO Data Management Presentation, is a link to a folder. If you could drop your PowerPoint in there, that would be really great.
Okay, I'll do that right now.
And I'm taking over screen sharing.
Okay.
Thank you. All right, so yeah, that's the folder link right there.
Got it.
Any questions for Luigi now that you've had a moment extra to think? All right. So I realize that our new online guidelines are very new. We just put them out 2 days ago. We, in the winter, described our products quite extensively with a series of reports, but didn't really have any guidance on how to use them. We gave guidance, but not really careful guidance. So let me do a quick overview of what we have. Let me first ask, if we actually look at the questionnaire, really the first question is, have you looked over our guidelines? Unfortunately, you only had 2 days, so Luigi typed in yes. I don't know if anyone else had.
Yeah, I jumped the gun. That yes was based on the previous web pages, so we should say no, not the new ones.
Okay, all right. Really nothing from our old guidelines is different, and we've kind of been saying the same message for over a year now, but we haven't really documented it very clearly. there shouldn't be any new surprises, but hopefully quite a bit of clarification. So for the sake of everybody, I'm just going to quickly go through what we've done. So the new Submit CZO Data page now, as I mentioned, describes some benefits of integrating data through here and lists these 7 expectations. And there's a separate page with detailed instructions on each of the expectations. In addition, at the very end, there's a list of 2 optional approaches that we will support, that we have funding to support. And I will flip through this, and we might consider actually changing the order in which we present these. And I might try a slightly different order of describing them. We'll see if that works. Let me just see here. All right, I'm just organizing my screen a tiny bit since I've taken over a presentation. So as we mentioned previously, data sets are, actually I'm going to go back a little bit. Originally, the whole idea of CZOs were to share data in a file format that could be ingested by CZO Central at the search.criticalzone.org portal, and if the data sets were of a certain format, this display file format, they would get ingested into a Hydra server, which then would have all the capabilities of a Quasi Hydra server and basically be discoverable on Quasi's infrastructure and visualizable using Hydra Desktop, et cetera. So that was the original intent. But what we realized was that even though the intent was lots of files could be registered at the CZO Central portal, the data managers weren't really doing it. They were only registering display files, and display files were only designed for hydrological time series, really. So an enormous amount of data, up to 90% of the data that CZO data managers were sharing wasn't being, 90% of the data they were developing wasn't being shared. So we created this this way to list data sets on CZO web pages, and I'm going to jump over actually to a different browser window where I'm logged in as an administrator or will be logged in a second. So if these data set listings, I don't know if you have anything here for IML, not a single one. All right, so we'll talk about this. So we were just looking at Hermes Catalina. So Hermes has, am I logged in? There we go. So Hermes has created these data set pages, and the idea was that all the data managers back in 2012 had become very familiar with using our website, and it was decided that it was relatively straightforward to fill out. So this is the back end. If what you just saw me do was, if I was creating this web page, I would log in through the admin page and come to this web form and fill it out. And some of filling this out is really easy. Like, you can just click on tags and they show up. You know, you have to cut and paste certain things, and you have to then create the links to the actual data. The data files in this case are being stored on Arizona's CZO Arizona's web server, data server. But a lot of these things, including people tags, are just, you know, you can just search, right? So we could just add Praveen in here. You know, so it's super easy to do. And so the data manager said, yes, this is easy, we like it. And it created a way to browse data sets on the CZO website that NSF really wanted to see. What we realized that we wanted to kill multiple birds with one stone, and so what we did is take all this information that's available here, including the pointers to these files, which are not stored at CZO Central, and we turned them into ISO 19115 metadata profiles, which are then cataloged by a geoportal server that exists at San Diego. And so the exact same files that I was just showing can be found here in a really nice, easy-to-use way. So this B2 desert site meteorology I can find quite easily. If I tagged climatology meteorology, it'd be like, boom, we're there. And that's the exact same file we were just looking at. Sorry, on a different web browser. This one right here. So this is a way to kill two birds with one stone and create a profile about the files, right? For a data set, and a CZO data set is a group of files. Whoops, sorry, I should go back to here. I'm sorry that I'm flipping around way too much. You might get a little busy from it all, sorry. But these pointers can point to any data resource. They can point to a data server like we have here. They could point to an instance of what you have, you know, a file that you have in Clouder. They could even point to a view that you have in your Geo, whatever it's called, your Geo dashboard. So these are just all pointers that can point to different components. And the ISO 19115 metadata profile, which is ISO International Standards Organization, this is actually the metadata profile that is recommended by NOAA and is being used by federal agencies for any data set that has geospatial information, any data set that includes multiple files with geospatial information. So it's actually very widely used. So and it allows us to federate and basically share the data, but it's just metadata about the files. So those could point to you, but one of the this is where I'm going to jump a little bit. The recommendations is that after a data file has been QA/QC'd, that it go to an archival data repository, and so the pointer that we use should be a DOI, so that the archival data center issues a DOI, or just like in publications from publishers, and then that is used to point to the data set. So we have we're ensuring that we're in the long-term archives, and so this describes why that's important. And we kind of listed it as a last step because at some level we'd like to do some other things along the way to get to that. But here are the instructions, and the first instruction is determine the appropriate data center or repository. And here's our list. We have, from the beginning, partnered with the Interdisciplinary Earth Data Alliance, IEDA, and with QASI. And QASI's cyber infrastructure has been solidified at the Water Data Center for time series and streaming time series data. But there's also funding to develop HydroShare, which is much more flexible, a little bit like Clouder, for sharing water data of all file types, including models and code, including geospatial files, a whole variety of things. QASI and HydroShare are just beginning to experiment with issuing DOIs, whereas IEDA EarthChem Library has long been issuing DOIs. So those are our recommended repositories because we've been funded to partner with them. But for biological data, we recommend others, these two in particular. And Clouder, if you have an archival mandate, and I don't know if you do or not, that's a question. And if you plan on issuing DOIs, could easily become part of this list. Any questions along those lines?
Yeah, sure. So which one can currently mint DOIs? I mean, they can actually do it right now. And let's say we wanted to publish, let's say, so IEDA does that right now?
The EarthChem Library, yeah.
Okay, so let's say we want to publish data to it. what's the policy? We talk to them and get an account, and is there a limit on how much we publish? Because I mean, one of the biggest problems, so for example, in the DataNet Seed project, we're developing all sorts of ways to publish to long-term preservation archives and get DOIs back. But the question is, it always comes up is, you know, who actually allows you or me in this case, right, us in this case, to put data there? So would IATA do that right now if we started, you know, doing that? Are there limits? Is any
I'm going to give a short answer, and then I'm going to hand it over to Megan, and maybe others might pipe in.
Okay.
So NSF has had, you know, cyber infrastructure projects for a while, but they're just recently, especially with EarthCube's initiative, consolidating funding around data centers with long-term archival responsibilities or mandates. And the recommendation from the data center group at EarthCube, and that I've heard multiple times from Kirsten Leonard, is that data should be submitted to a repository that actually, if we go up here to instruction number 1, to determine the appropriate data center for your data set based on scientific discipline and data type or data domain. So if you are funded by NSF and have solid earth, geochemistry, mineralogy, or related data, IATA actually has a mandate to serve you. So tell me a little bit more about that, Megan, what you can accept and what you can't accept. There are limits to all these things. If you've got terabytes of data, people will likely turn you down. If you've got you know, hundreds of gigabytes of data, you'll have to talk to them.
Yeah, so in terms of how much data we can take, I can't really speak to that. You know, up to this point, it's been, you know, spreadsheets or zip files, but we can certainly discuss. I don't think anybody's really sort of tested our limits in that regard right now. But Anthony's right. Any sort of solid earth data, we actually have pore water chemistry and stream water chemistry in there currently from the Shale Hill CZO, although that data may be better served elsewhere. We have a lot of soil geochemistry. We have physical characteristics of soils like grain size distributions and things like that. We can help you get a DOI. We can also put an embargo period of up to 2 years, so you can submit your data and get the DOI, but not actually expose that for download to the public for that period of time, so that you can use the DOIs in your publications. That's a really important thing, as you know. We have a series of templates that you can look at. I believe that they are linked if you click on that EarthChem library data submission guidelines. It's pretty easy to find. And we have a series of templates for bulk chemistry and a variety of other measurements, including isotope data. We are always looking to increase the number of templates that we have. So if you have a data type that you think is appropriate for our repository but isn't well served by one of these templates, we're happy to work with you to develop that. Yeah, and we encourage, I think we're going to talk about this in a moment, but we also encourage, along with the submission of these templates, we encourage the use of the International Geosample Number, the unique identifier for physical objects and sites. But I think we'll talk about that in a moment.
Can I say something? This is Praveen.
Yeah.
So there is a certain philosophical question here. Most of what you are describing is basically discipline-oriented. Kohasi takes in time series, mostly hydrologic data. EarthChem takes in a lot of the chemistry data and so forth. The critical zone science is designed around enabling interdisciplinary science.
That's right.
And so if we fragment the data and send it out to 10 different places, and then go back and say, hey, what data is available for this location? I will not be able to find all the pieces that went into all the different fragments to be able to do interdisciplinary science. So one of the ways we are developing our system is to basically know what are the different types of measurements that are at a particular location independent of the discipline, so that we can do interdisciplinary science. So that's one thing, a question that has never been answered. There are a lot of these repositories. The way you are taking the data into the CZO Central and putting it, soil moisture, soil temperature, and all those things, yeah, we can find those. But at some point, somebody has to put it together saying all these variables are at this location, and therefore you can do these interdisciplinary questions and so forth. Mm-hmm. So that philosophy of supporting interdisciplinary science through data, archival, because the data representation and archival will or will not enable certain questions to be answered. Is that an underpinning question in there? Now, that's one, and let me finish part two of this. The other thing is, a lot of this data, the way they are being represented is for manual consumption, which is saying that, okay, you can go and find the data and download. There is, with the EarthCube and all those efforts, there is significant effort on automatic consumption of data by putting in semantic layers over on top of them, so that we can do a lot of, say, model data integration automatically or other kinds of analytical procedures on those. Are there semantic layers or that kind of a thinking in the sort of stuff that you are doing? Because if we fragment these pieces and send it to you in whatever ISO standard, that's fine. Somebody has to then resynthesize those and extract those out, the relevant pieces out. So is this compatible? Is this part of your thinking? Is this something that we should be aware of?
Yes. So let me answer that. That's an excellent question. So, here are data sharing instructions and guidelines. List data set at criticalzone.org, and I jumped all the way to kind of what we think is the last and most important thing to do, which is to put it in an archival data center where it can be stored and in permanence. But what I did was I skipped all the stuff in between, which is really aiming toward what you're discussing. Within I will say, the kind of funding constraints that CZOData has had from the beginning, which is we don't have a mandate to develop an archival data center. We don't have those kinds of resources or long-term commitment, right? This was a 2-year project. So let me describe some of the things in between that we hope will get us to that place that you're describing. But what you describe is absolutely right. Data one, the biological networks for storing data, all they have ever achieved is a great way to tag files so that you can find them. But the job of integration has still, to this day, in the Data One network, requires you to go find a whole bunch of files and manually figure out how to merge them. And that is not the future of cyber infrastructure. Totally agreed. Our group is completely behind that statement, that we want to have much finer levels of integration. And that is why our group put such an incredible amount of effort on ODM2 and the observations data model, was so that we could achieve that goal of data integration. And I think I'm going to say one more thing. I'm going to go back to this DOI page. Of all the data centers that we were aware of when this project started, the only 2 that did granular record level data integration that would allow you to search for calcium content of rocks collected by anybody over a geographical location using any method was IEDA EarthChem database, or PetDB and their related things. The only data center or repository that could allow you to search hydrological data sources measured by anybody over any number of variables was Quasi. All the other data repositories didn't allow that granular level characterization. And in the very beginning of the CZOs back in 2009, there was a bit of a battle over how we should do it. And there was a lot of arguments over, no, we just do it the way that the biologists are doing it, bag and tag the data files and everybody can go find them. Well, at the core of what we believe was that is not enough. we need really granular level integration. And to get there, it requires actually a totally new information model, which is why we basically went down the path of ODM2 for so long.
But does ODM2 solve your problem, because its design is based on a relational database model?
It solves a lot of problems, because actually it's true that our original set of concepts, we worked within kind of relational database space, but one of the things that we intended from the very beginning, that this would be a full-blown information model, not a relational database model. And so we have spent quite a bit of time doing object relational mapping, so that the concepts that are in ODM2 can be distilled into, the programming world of object-oriented programming and class, subclass structures of objects that each have different, methods and other attributes that can, a certain set of attributes, and then optional attributes, and then methods that can be applied to them. So we've taken the time to do that, and there's a lot of semantic information that ODM2 inspires that is not that does not require an ODM2 relational database. ODM2 is actually, it sounds like it's a derivative of ODM1. I think we liked the name a lot, but really think of ODM2 as being more a derivative of OGC's observations and measurements. Are you familiar with that standard?
I'm not.
Yeah, so the Open Geospatial Consortium developed the observations and measurements data standard for how to relate Earth observations and measurements to sampling features that are representations of features of interest on the Earth, and that is actually the core of what we built off of. And that is not a relational database model. It's much more abstract than that.
This is Marian, and I cannot abstain to not make a comment. I'm around for some years, as an engineer with interest in this domain, and I was involved in HIS Central. Now the quasi data center is out, HydroShare is out, your resources are out. We have this collaboration with NCSA. And I see the same thing. I mean, we multiply this type of computer view to our domain area, and really I need a system which allows me to look place-based to the data. So definitely, I just learned now that AIDA maybe does that thing, and I think that from even CZO, and Praveen pointed out, from CZO perspective, this is exactly what we have to do. We have to work on the map, looking for the data, and to not know anything about the repository. So that's what we try here, but it's very little development because we are not specialists and we don't have that big view of what's needed for that in the back end. But I think that this is critically important for our future, Praveen, for the CZO project. If ODM2 brings more of that, opportunity, we should focus as a team with CZOData, who knows more than us about ODM2, to do something around that thing.
So our vision is very much, I think, like your vision. This idea of automatic ingestion, which I think you've come a long ways with, is really exciting. Emilio said we could have, hours of conversation about how to collaborate on that. To do that, you need structured data with well-known semantics and, of course, syntax. So that is, we had to start with ODM2 to get there. The next recommendation here is that the files themselves, even though data sets can be listed, the data set listings, just like in Clowder, can be any file type at all, you know, and the CZO website just points to them, and they point to them anywhere, preferably at an archival data center, but all of these archival data centers also allow any kind of file. And then the archival data centers like AIDA and Quasi and LTR information system and et cetera, they add extra features if you put the data file in a certain format. And we built some extra features around these files called CZO display files. But the CZO display file was really built to serve hydrological time series. And so we realized that they had, the CZO display file had a limit of lifespan. And so we developed the CZO display file version 2, which we decided to rebrand, just the way you guys did, around this idea of YODA files. And it shares some of the same concepts, but really quite a bit of difference in terms of the semantics and also the syntax. YODA file stands for YAML Observations Data Archive. We also see it as an exchange format, and YAML is a data serialization format. If we go down here, in this page, YAML is a data serialization format, which is a superset of JSON. So all JSON, everything that's JSON will be parsed by YAML parser, but YAML actually both embraces JSON linked data, but goes a step up above that and allows all sorts of other things, features like internal references and comments and things that JSON doesn't allow at all. And on top of that, YAML is easier to read than JSON. It removes all the squiggle brackets and quotes. But anything that's JSON will parse into YAML. And so we decided to build the next version of the display file on YAML. All modern computer languages have well-tested libraries that can parse YAML, and we're then building upon those libraries to build features of YODA files. These YODA files are unfortunately not quite yet mature. We thought we were close in the spring. To be quite honest, our hydrological time series YODA files are quite mature, but the templates for building them and the functionality around doing it programmatically straight out of a database are not that mature yet. But it is really a primary focus for our team now. One of the other things that came out of ODM2 were vocabularies. Obviously, vocabularies are a very important part of semantics, and here's some description about vocabularies. One of the first things we say is look at our recommended control vocabularies, and our primary one is our ODM2 control vocabulary. That ODM2 control vocabulary took an enormous amount of effort and is quite mature now. We're quite excited about it. There are two levels of effort. The first one was actually going through all the existing vocabularies from Quasi and AIDA and elsewhere and merging them. So for things like medium vocabularies or specimen type vocabularies or a number of other method type vocabularies, we actually took the best of the best from a Quasi and AIDA, merged them, and also went out and found other vocabularies that might be relevant and added them and created a great list. On top of that, neither AIDA or Quasi has ever had a vocabulary system in a SCOS or a simple knowledge, what does the OS stand for? Something system that delivers RDF, so that basically machines can communicate about things. So with a term, you can go fetch a definition all programmatically from code. So you can build software around this. There are SCOS systems that exist, but unfortunately, those SCOS systems don't also have the ability to edit or add new terms by the community, which is something that Quasi has had for quite a while. So Jeff Horsborough's group built a hybrid of a SCOS system with editing capabilities that's really quite exciting. So we have, this system is being widely used by the cyber infrastructures that are adopting ODM2 for their new core. So Quasi's HydroShare is building services around ODM2. Quasi Water Data Center is considering ODM2, although they really have their hands full with just moving to the cloud. IDA has already is well down the path of building cyber infrastructure for their EarthChem database, which is the kind of the derivative of all their various previous databases, including PetDB and CZODB and all these databases that they had built over the years. And also the CSAR system is built largely around ODM2 concepts. So this international geosample number, which I'm going to jump to in a minute, their international governing body just recently adopted the ODM2 control vocabularies for medium and specimen type, for example, because they're the most complete. So this type of semantic work that came out of ODM2 has been a humongous part of our workload and effort, and really is very mature. So as much as possible, use YODA files and start using ODM2 vocabularies. There is a need for continuing to use Quasi version 1.1 vocabularies when interacting with the present Quasi Water Data Center or with CZO display files, which your team probably won't ever try to use. And there are some IDA EarthChem control vocabularies that are still relevant because we haven't fully merged them yet, and it's specifically just about variables. Most of the other vocabularies have been merged. So international geosample number is a huge, important part of integrating data. And it is a system that can be used not only for specimens, which is what its primary design was, but so that you can keep track of samples and subsamples and all the data that's associated with them. But it is actually in a broader context, these universal international IDs for sampling sites, weather stations, stream gauges, soil pits, any type of site. If you register a sampling site with an IGSN, that IGSN can be used as a parent to link all relevant data under the hood for that. And over the last year, actually more than a year ago, about a year ago, we developed very specific templates and guidelines for CZOs to use IGSNs. So our recommendation is register your sample sites with IGSNs, start using that sampling site IGSN in all of your workflow. This is going to enable the automated harvesting of the files that you have in Clowder, and if these numbers are highly recommended within YODA files, so that under the hood automated integration by the type of discovery tools that you are beginning to develop with your Geo dashboard or our own CZO visualization system prototype, all of them can use these numbers. And then once you've done that, obtain IGSNs for field and lab specimens. You don't have to have every single lab specimen have an IGSN, but if you're going to analyze it more than once, subsample it, share it, or archive it, getting an IGSN is really important because again, IGSNs allow this whole parent-child relationships between specimens and sampling sites, and all of that can be brought back together using the data system that's at CSAR. Last, IGSNs have this ability to create linkages in publications. So major publishers, and this is an article posted up on the CSAR website, shows how publishers who are creating services around linking papers that use the exact same IGSN. So again, this is about integrating data by sampling site across the entire scientific literature.
Quick question, Anthony. This is both for the site as well as individual samples?
That's correct.
Okay. So at a minimum, we can do the sites by going through CZO and basically register online. But for the physical sample, that would require, how do you do that since you have a physical sample? Like, do you send a physical sample? Do you give it yourself? So, you know.
You want to respond to that, Megan?
Yeah, sure. So we don't actually need the physical sample. We just need you to register the samples, which can be done in 3 different ways. We have web services that you can access if you want to register a lot of samples all at once. There's also just a batch way, which is just an Excel template that you can fill out a very small amount of metadata up to a lot of metadata, however much you want to put in. And you just basically, sorry, go ahead.
No, I was just going to say awesome. No, this sounds really exciting. Yeah. And I didn't realize you were, you would allow the user to do that process and just submit the information about the sample, which is really nice. And
there's also a way to register samples individually. Obviously, if you have a lot of samples, that's not very efficient, but you can, if you want to just get one IGSN very quickly, you can go in and do that and get the IGSN immediately. Otherwise, the batch way takes like a couple hours maybe. I usually need to send something back to you, but it's usually very fast. One thing people have been doing a lot lately is actually sort of pre-reserving IGSNs, that is getting IGSNs and generating labels before they actually go on a sampling campaign, so they can actually take those labels with them out in the field and have them associated with the samples from the moment they are collected. So that is something we can work with you on if you're interested in that as well. You can also keep your metadata private if you choose to do so for a period of time. There are a lot of other cool aspects of CSAR and IGSNs we can talk about separately.
Very cool. Thank you.
CSAR has a whole bunch of web services related to IGSNs, and it's one of the things that we developed for the CZO data visualization portal. These IGSNs are let's see here, I don't know if I've got the right one, but essentially the IGSN web service can be ingested in visualization systems like this or like your Geo dashboard. So the web services around this are valuable for plotting information, and with an IGSN, you can then go find data that is connected to that IGSN. The most important aspect of IGSNs is I'm getting tangled up with. Oops. There we go. Here's an example of a landing page that resolves that IGSN right there. This one is for Lucio CZO, which describes metadata around this rock sample, or actually at the core. But here's the beauty, so it has location information, other things. But what's really important is the relationships to the borehole and all the sibling samples that came out of that borehole or that were subsampled out of that borehole. I haven't studied this to see the organization scheme here, but parent-daughter relationships, I guess siblings are, so it has no children, so there are no subsamples, but these are all the siblings that came from that same borehole or larger core. So this is how we do data integration, is with tools like this, and this is all has web services enabled around it.
Very cool. And so this is different from CSAR, the geosamples.org, or is this related to it?
The website for CSAR is geosamples.org.
Okay, thank you.
Yeah, I don't really know why that happened, but there must have been a problem with the URL. So CSAR, geosamples.org, same thing. So so Yoda files, vocabularies, IGSN. I will state that the information model that was used for IGSNs was one of the important components that we ingested into ODM2. So there's a huge linkage between here. ODM2 can completely manage the metadata that gets loaded up into IGSNs and vice versa. So, so there's just an example about the, you know, we really wanted YODA files and ODM2 web services to be able to handle this complex metadata about related sampling features and related sites and related specimens and their connections to each other. It's an enormous amount, it's an enormous part of a requirement for data integration in solid earth and critical zone science. So this is a really big part of what we're doing. I'm going to jump over. Yeah, go ahead.
Here. I have to leave in about 20 minutes.
Yeah.
What are the things that we need to accomplish today in terms of where we want to be? Yeah.
So thank you for getting us back to kind of where we want to be. So that was kind of answering some of your questions about how the CZO data system helps integrate, and it shows these different aspects of what we are doing to kind of build the bones for integration. The actual ability to do the kind of queries that you have, we only had some prototyping money to kind of do a demo via this visualization portal. But what we're trying to do is build the capacity, kind of the connections, the semantic connections that enable this to happen. So why don't I skip over the rest of this because you can read it. Implementing ODM2 locally for data management is completely optional, and you guys don't really need it. And the same thing goes for streaming data. You've really got that under control, it seems like. So those are the kind of the main points I wanted to make about that. It seems like if we go through this set of questions, we've got questions about YODA files and I guess there's one question here that we didn't quite answer. And that was this question of, can we create data set listings? Do I have examples? No, it's in my other web browser. Like this, automatically, based on what you all have in Clowder. And it may be possible, but it would require some work on your end. So we developed a way to import these data set listings from CSV files, and David Lubinsky could discuss with you how to create basically instances of web pages that are like this from CSV files so that it doesn't require manual input from you all.
So we can't use YODA to populate this, which is fine. So we really want to see if we can create the YODA files on the fly for you guys to pick them up. But my understanding is that those will still be separate from what appears under criticalzone.org, right? That you're not planning on using the YODA files to populate criticalzone.org. Is that correct?
That's correct.
Okay.
So the criticalzone.org dataset page is kind of considered a grouping of one or more files, which we recommend be YODA files because the YODA file allows us to automatically ingest the information like IGSNs and the metadata and the data values and all that other information can be harvested right out of the YODA file for ingestion into these integrative data systems and databases. However, what we're posting here is a little bit more and outside of what is in a YODA file. some of it is somewhat redundant, but the ability to kind of cross-tag with researchers and find, all the data sets that they're associated with that researcher is associated with is something that we wouldn't be able to get out of a YODA file.
Got
so.
It. Okay, that's fine. These are more clarifications, just to make sure that we understand what our possibilities are.
Well, it should be possible to bring YODA files directly into the search interface. Because, for example, the search.criticalzone.org already harvests data from this site, criticalzone.org, but also it gets a catalog from LiDAR, and it probably can integrate with your catalog as well. That could be one fairly tangible thing that we can try to accomplish, so that you manage your data, but we will allow cross-CZO search for your data as long as you maintain some good descriptions, which you already do anyway.
That requires a common. We need to talk about a common schema, and that was the other one we were talking about more. So that's the thing, is that the minimum of a Dublin core type of set for searching, but the other part of that return is, as was described, is we need to also kind of standardize the endpoint description so these things can be automated.
Yeah, you tell us what you want and we'll make it. I mean, I'm talking about, like, even if it has to be very specific to your catalog, that's fine with us. We're more than happy to do that development.
Yeah, so at this point it's CSW ISO, so it's very standard.
Okay. So now,
let me say, there's kind of a conceptual difference between a YODA file and these CZO data sets. NSF specifically asked, so we were trying to develop this catalog with search capabilities, and it didn't, and admittedly, back in 2011 and 2012, it did not have, it was more like 2012, it did not have a very good user interface like it does now. But NSF finally said, we want to be able to browse using a normal web browser on a web page and just have a listings like this. They really requested it. And actually, it wasn't just NSF, it was the CZO advisory committee that suggested that. So we were kind of a little bit stuck because we didn't really initially intend to do this, and we saw that things would get overwhelming. So what the intent of these data sets on CZO Central is really to aggregate like files that are of similar content, right? So for a given site, or to group things, right? So the intent is that multiple YODA files would be potentially listed and grouped together on one of these pages. The entire page or the grouping of files or the individual files, either one are discoverable at search.criticalzone.org.
Yeah, no, and definitely, I understand that we want to populate criticalzone.org. That's clear, and it's just, it's just, I was wondering if we could do it, both one way by providing you with the YODA file that would go to criticalzone.org, and that criticalzone.org would appear on Data Search Portal. But if that's not the case right now, that's perfectly fine. I'm interested in hearing, not now, but to pursuing the idea of maybe creating the CSV versions, if that's a possibility. If you give us a simple way to post the CSV, we can do that programmatically. If you want a manual upload of the CSV, that's also fine. I mean, that's really your call. I see that the form, as is very nice on criticalzone.org to fill that in. It's just the manual labor of having to do that twice that we're trying to avoid. That's it. Otherwise, if we have to, we'll fill the form. I mean, if we have to, we'll fill the form.
No. So the CSV, I guess the point I was just trying to make was, CSV we can do, but it's not a one-to-one. We don't want one of these. We don't want one of of these pages for every YODA file. That would be too much. It would be too much to browse. The point is that these are supposed to group like-minded sets of files or similar sets of files, right? So this page, this data set, you know, every year should get like another update of several files on the different data sets that are here. Each one of those being a YODA file. So it's not going to be a one-to-one. So it helps to have some kind of logical grouping for browsing that of the YODA files. So it's going to be a two-step process, and just think of this as a grouping of YODA files.
Yeah, and we have a similar thing in our data management system where we literally organize all the data sets by site, and then
Perfect.
like you're doing here, and so we can definitely map to it. And I understand you only want to have the high-level sites and data here. So each CZO potentially doesn't have a huge list, an endless list.
That's right.
More thematic. That makes perfect sense.
All right. So David Lubinsky is the person to talk to you about the CSV file.
Okay.
We've already done this. We did this with actually a number of the CZOs who gave us CSV files and kind of automatically created these pages. That said, there was a little bit of work that you had to go through and preview them before they went live. Okay.
So then so we'll talk to David about the CSV to critical zone. Critical zone, and then potentially talk to Ilya about the catalog and the YODA files. If that's an option, it might be unnecessary, but if that's an option. I wanted to mention real quick before we end that for the EarthCube project, we are working with the ODM vocabularies, the page that you showed, because one of the points of some of these tools that we make is that they are not vocabulary dependent, but you can provide your own vocabularies. So ODM is one of them that we're currently looking at. CSDMS was one that we already did. So hopefully soon enough we'll be able to provide a lot of the metadata that we currently have using ODM vocabulary. Do you want to say anything else about that? No? Okay.
That's awesome.
I just wanted to mention that. So soon enough we'll be able to show some of that in working. And Praveen?
Go ahead, finish the technical.
No, but besides that, I didn't have any other. I also have a hard 4 o'clock, so I apologize.
No worries.
I just want to say this has been incredibly helpful. It took us a little bit of time to get our systems, in a place and start getting data in. We're still heavily involved in that. But, we'll do whatever it takes to make the flow of information from our local site to your tools as easy as possible. And that's really, the route that we're going at it is, to kind of put that in the hands of the researchers. Of course, there needs to be some QA/QC, but, to make it as in their hands more than ours.
So, Anthony, Praveen here again. Given the sophistication of our system that we have and our ability to make the data available through our system, the value that I see of contributing to the CZO Central is basically supporting cross-CZO search, right? I mean,
that's right.
The data is still staying in our system. It's essentially the metadata that is going, and that enables cross-CZO search and be able to find various data. Is that a fair characterization?
That's definitely the primary benefit. So the primary benefit of creating pages like this, and hopefully your team can get together and say, yeah, these are all thematic. These are going to be the way in which we group things thematically. And you could go through each of the CZOs and essentially look at their data listings, right? So you can kind of do it like this, right? So these are all the data sets that are out there by Hermes Catalina. You could look at the bolder ones and kind of see how they've grouped their data sets. And then once you've got that, send us the CSV file that contains all the metadata, for these groupings, but the actual the actual files themselves won't really be files. These will be, the data will just point to your system. There's no need to do anything with it. We just need to point to it.
But the data in our system is not structured in a very easily accessible way. I mean, it's structured in a much deeper level.
So there's more, yeah, our hierarchies are a little taller or deeper, whatever you want to call them.
So the only way to access our data would be through an API interface rather than a direct link.
No. We can link to the Clouder pages for example, broadcast the collection is a site, and then a collection is a data set. So that URL there could point to the collection. It doesn't have to point to the site. Because the moment they jump to it, or the data set, the moment they jump to it, they come to our group.
But you have a unique URI for each collection?
Yeah.
Okay.
In each data set, in each file. Yeah. We can do it.
Okay.
Yeah, we can approach data integration at multiple levels. So the first level, of course, is discovery across multiple sites. And for that, we just need some metadata characteristics for your data put on criticalzone.org and eventually showing up in search criticalzone.org. Ideally, it would be not two different interfaces that you need to develop for CSV and YODA, but just one, and then we would use it for both systems. But then, of course, the deeper levels of integration is when you need to understand what is in the data, so semantic layer, and in our case, that's controlled vocabularies that Anthony talked about, and also we will be embedding semantic references in all ISO files that we have in CriticalZone, in search.criticalzone.org. And then ideally there should be a somewhat finite set of, not very large set of web services or APIs that we use to access different files. Right, so if we can access your files via the APIs that you provide, and then make this access transparent for the visualization and search tools that we have, that would be the next level.
So who would be responsible for ensuring compliance with data sharing policy? Would it be you guys or us?
We need to talk, I guess. Since we are trying to do it across all CZOs, we probably will be the point of contact, but your experience in developing this system is an impressive system. So whatever we can borrow, we will.
But in terms of compliance, right, to check things off the list with NSF, I really think that if you create data set listings that point to files on your resources on your server, or I can't remember the exact term they used, that has a URI and that or multiple URIs, right? Remember, a data set is a grouping. So if you have your profile, your higher level data set that then points to multiple views out of your data system, and that gets cataloged by us, I mean, that allows this cross-CZO discovery, and in each of these there's an acknowledgement and ability to harvest information about the funding source. So we would be able to basically check that off the list, or when CZO asks, when the NSF ask us, I guess, is the CZO contributing? That's how it would be seen. And
yeah, but no, my question was a little different, Anthony. Basically, for our CZO, we have 3 levels of sharing. One is basically data that is openly accessible to anybody. The second level is that data is embargoed for 2 years.
Yeah.
And the third level is that the data is not shared, only the metadata is shared. And this applies to data that we may have gotten from other partner agencies, and we don't have the right to redistribute them. But we can expose what we have. So when somebody clicks on a link, we would need to ensure that the data which has been classified in one of those 3 categories, some of those things are met, and I don't know who will be responsible. We'll have to do it at our end, I'm guessing.
Yeah, so exactly. So we do that. There are lots of CZOs who do that. Actually, I'm going to go to our CZO just because, because I know our data set a little bit more, but we have embargoed certain data, and it is when you go down here. Oh, I grabbed the wrong one. It's not a hydrology, but anyways, you go to one of those links. It's the Streamwater Chemistry one. You go to one of these links, and it is private. Actually, we might have lifted the embargo, so maybe I'm not showing you a good example.
No, that's fine. I mean, I understand the concept.
So the idea is that if you're pointing toward your system at a URI that can only be accessed with a login, the user is basically faced with a login, and they can't go any further. But you still have the pointer pointed to the right place. And if it's a persistent URI, as soon as the embargo gets lifted, yeah, these embargoes all got lifted. So I'm not really showing a good example, but yeah, so that data is already available. So we don't have anything that's embargoed right now, but our system, by being a pointer to your system, allows you to control permissions completely at your end, and a lot of the CZOs are doing that.
Okay. Anthony, I think we are starting to disperse here.
Yep.
On a tight schedule. So was there anything last moment that you wanted to add to this discussion?
Yeah, so sorry that we came right up to the very end, and I apologize, Praveen, if I got a little bit off track. I think the very last point is that pointing to your resources with URIs is really the first thing you should do, and then as you already are using vocabularies, if you start using IGSNs, and then eventually YODA files, when they become available and as kind of archives of these data sets or resources, that will enable this kind of cross-CZO integration down the road. But really, kind of the highest priority is probably getting pointers to your system in our system, so that we can catalog those pointers.
Yeah, and also we have to make some strategic decisions in terms of human resources because we are spending a lot of time in contributing and developing the system to support our own researchers. And if adding to the CZO Central is going to take away from that, then we have to make some hard choices. So we'll discuss with Luigi here, as the more automated we can make it, the better it is. But if it's going to require a manual process, I'm going to push it for months out. But if it is automatic, and if there is ability for you to ingest, we could create scripts, take our metadata, feed it into the thing, and at your end you can digest that. That will significantly speed up the process. I'm probably unwilling to commit any manual time to this simply because we are under pressure to support our own researchers, because our own researchers are using the Clouder and the system to make decisions. I mean, we have almost real-time streaming of stream flow. People, when there is a storm system coming, people look at it and say, well, do they need to go out in the field and so forth. So we're trying to support that kind of an activity, and we are under time constraint. So we have to make some decisions, and we could use your guidance. The more you can help us automate this, the easier it will be for us to contribute to the CZO Central.
Let's make sure that Luigi and Brock and David Lubinsky and maybe some of the folks from San Diego and I get together and get you set up, because we have the capabilities to ingest CSVs of the metadata for those web pages and automatically ingest them.
All right.
Thank you, Anthony. I got to run as well. Thank you all for your time and support.
Sorry for the abrupt end, but we have to go, Anthony, and thank you
everybody
for all the effort. This is looking good.
All right. Thank you.